Hi everyone, it's Deli. Welcome to the study guide review video for the 7th grade Math Unit 1 quiz. The quiz you'll take on the computer, but it's going to be very similar to this, and I will have a couple paper copies available for you to reference. The quiz will be just like the study guide, almost to a T, question by question, super aligned. So if you understand and can do all the questions on this study guide correctly, independently, then you should be totally set for the quiz. Alright, question 1. Juan was asked to determine the scale factor from figure A to figure B. He said it was 3. Explain how we can know that Juan is wrong without even doing any calculations. Then determine the correct scale factor from figure A to figure B. Okay. So looking at this, just pick one of these sides. This down here is 3 units. And then that corresponds with this piece, which is 1 unit. So the core thing that we have to recognize, how I can immediately look at this and know that Juan is wrong, is because from A to B, and that's the direction they're asking us about, the shape is getting smaller. We have a scale copy that's smaller than the original. And anytime our scaled copy is smaller than the original, then we know that the scale factor has to be in between 0 and 1. So it can't be 3, because that would mean we would be multiplying by 3, right? And then we'd get 9 instead of 1, and that's not what's happening here. Okay, so Juan is wrong because figure B is smaller than figure A. Thus, the scale factor from A to B must be between 0 and 1. Okay. Juan's not getting that 3 from nowhere, though, right? 3 and 1 are related, and if we were going in the direction from B to A, then the scale factor would be 3. From B to A, we're multiplying by 3. So the correct scale factor has to be the reciprocal of 3, which is 1/3. Right? Reciprocal is like, we think about it as like the flip of a fraction, but it's the number that when multiplied by whatever it's the reciprocal of is going to multiply to give you 1. So 1/3 and 3 multiply together to give you 1. So the correct scale factor is 1/3 because, right, it's the reciprocal of 3. And we have 3 in that other direction. Okay. That's actually longer, like it's a harder question than you're going to have to do on the quiz for there, but the concept of this, when we're multiplying by a scale factor in between 0 and 1, we get a smaller shape, is really that key concept. All right, question 2. This is kind of a tricky one because it's a select all that apply question, so it's just easy to make like sort of a small mistake on these. But for any of select all that apply questions, you really just want to take your time, go through every single answer, and consider it independently, right, of all the others. Don't assume that because it's select all of the apply, it's going to be 2 or 3 or 4 or 5 or 1. Just go through every question and think about whether it makes sense. Okay, so it says polygon EFGH is a scaled copy of ABCD. The scale factor from ABCD to EFGH is 4. So from ABCD to EFGH, we have a scale factor of 4. Okay, so it's getting larger. Select all of the true statements. Oh, whoops, I made a typo. I do that a lot on these because I'm just taking the original questions on the test, on the like actual quiz, and then I change them. So sorry about that, but select all the true statements. First, we have segment GH is 24 units long. Okay, so actually before I go through that, let me just kind of fill in the information that I know based on the scale factor. So since CD is 6 and my scale factor is 4, then I know that GH it has to be 24 because 6 times 4 is 24. Okay, I can apply the same logic here. If BC is 4, then GF is going to be 16 because it is 4 times 16. And lastly, AB is 3, so EF is going to be 12. 3 times 4 is 12. Okay, now that we have that information, we don't know about AD. Now that we have that information, we are checking, is segment GH, is it 24 units long? And yes, it has to be 24 units long because we have that scale factor 4, right? We already marked it here. Cool. All right, next we have question, the second option, the distance between EH is 4 times the distance between AD. Okay, so let's look at that. Here is E and H, and here is AD. So what's tricky about this is we don't have any numbers for these. We don't know how long AD is, and we don't know how long EH is. However, we do know that this is a scaled copy, and we know that the scale factor is 4. So this is true because, right, we don't know actually what this is, but whatever it is, we'd multiply by 4 and get that, because that's how a scaled copy, scaled factor works. The ratio of 4 is going to be the same. So this is trying to kind of get at the same idea. Can you understand this relationship, what it means to be a scaled copy, what it means to be proportional, having these equivalent ratios, even if the numbers aren't there? Cool. Next one, the scale factor from EFGH to ABCD is 4. So that is going in this direction from the bigger one to the smaller one. Okay, that, since it's getting from a bigger to a smaller one, it has to be, just like in the question above, in between 0 and 1. If the scale factor from the smaller to the bigger is 4, then from the bigger to the smaller is going to be the reciprocal of that, which is 1/4, not 4. Okay, so yes, we're dividing by 4, but scale factor, again, by definition, means multiplication. All right, cool. Next, if the area of ABCD is 10 square units, then the area of WXYZ is 40 square units. So we're saying, okay, I know this area is 10. Does that mean that the area of this has to be 40? Now, we might think that's true because we have a scale factor of 4, but we learned in class that area factor and scale factor are different. So actually the area changes more than the scale factor, right? So because we're changing all the different side lengths, and then we find the area, we're multiplying it together. So this is not going to be correct. Okay, area factor does not equal scale factor. We want to be able to find the areas, but it's not like the same times 4 situation. So that's an easy trick question. Like an easy question to get tripped up on. All right, and then finally, the ratio of BC divided by BD is equivalent to the ratio of FG divided by EH. So I'm going to go here, and I'm going to find these side lengths. So what I just did is I saw what these were, where these were located. So I have BC right here, and then I have BD, which would be like connecting these, even though there's not actually a line connecting them right now. And then we have FG, which is here. So FG and BC, right, those are aligned. They're in the same spot. But then we have compared to EH, which is connected currently. It's that longest side. So these ratios are not equivalent to each other because even though we have a scaled copy, these aren't like corresponding parts. They don't match up with each other. So if we had something different, if it was like BC divided by AD, right, then we would have, this would be correct. There would be a proportional relationship because we'd have equivalent ratios. But since these aren't corresponding or matching, right, they're not talking about the same part, those are not going to give us equivalent ratios. So that is incorrect. Okay, not corresponding or matching side lengths, right? Those don't match up. Going on to question 3. Figure B is a scaled copy of figure A. Label each missing length so the side lengths of B are proportional to the side lengths of figure A. Again, proportional means we have equivalent ratios, right? And for our purposes right now, it basically means we have a scaled copy, right? We have a constant number we can multiply by. The ratios are going to be the same. So here I look at this and I say 5, 15. So what's the scale factor there? I'm multiplying by 3. So if I want to fill in all these other ones, I can also check that with this one. 2.5 times 3 is 7.5. Remember, you will have a calculator, so you can always use that. So to get my missing ones, I have a base down there of 6. So I'll multiply again by 3, and this is going to be 18. And then lastly, I have that side of 1.5 times 3 is 4.5. Okay. In order to scale figure A to figure B, what scale factor should you use? We used a scale factor of 3. And then in order to scale figure B back to figure A, what scale factor should you use? So here we're looking at that reciprocal concept. So from A to B, the scale factor is 3, right? We're multiplying all the side lengths by 3. So if we want to go in the other direction to get from the big one to the small one, we're going to be multiplying by the reciprocal of 3, which is 1/3. Okay, so that's going to be my answer to 3.3. And how do you know 3 and 1/3 are reciprocals? Yeah, I mean, that's good. I would be good with that. You could say like 4.5 times 1/3 is 1.5. Anything in that realm is good. But reciprocals is sort of that key word and that key concept that in either direction we have the reciprocals. Great. All right, question 4. Are the side lengths in figure 1 proportional to the side lengths in figure 2? Explain how you know. Okay, so again, proportional means equivalent ratios. So we're basically being asked, are these scale copies, right? That's just another way of saying it using the word proportional that we'll use a lot this year. So are these scaled copies of each other? Taking a look at this, the answer is no, right? Kind of visually, these don't look like the same shape. And then we can try to explain why using some of these ratios. So like figure 1 has a height of 2, and figure 2 also has a height of 2. But figure 1 has a base of 6, where figure 2 has a base of 3. So if we try to find the ratio of like the height to the base of these two triangles, we would get 2, 6, and then we'd get 2/3. And those are not equal to each other. We don't have equivalent ratios. Right? There's not a constant number we can multiply by. Okay, like you could also say that, the height, to get from the height in figure 1 to the height of figure 2, you're multiplying by 1, like that would be the scale factor. Where for the base, you'd be multiplying by half. So we don't have the same scale factor. All of those are really sort of saying the same thing. Okay, we're not scaling both pieces by the same thing. All right, awesome. 4.2, draw a scaled copy of figure 1 from the previous question using a scale factor of 1/2. Okay, so here we're drawing a scaled copy. We see initially that my base, we said, is 6. So to get this, I'm going to take my base of 6 times my scale factor of 1/2, and 6 times 1/2 is 3. Okay, so my new base should be 3 wide. We had the original height was 1, so I'm going to do 1 times my scale factor of a half. Oh, sorry. Oops. My original height was 2 times the scale factor of a half, which is 1. So my height should go up 1. This across was the top was also 2. So then now it should be 1. Okay, and then we can sort of just do this connection. This was 2 diagonal, so now it's 1 diagonal. So any version of that, we now have, this is called a trapezoid, and we have a trapezoid that is a scaled copy of figure 1 with the scale factor of a half. Always good to label it, right? This is 3 now. This is 1 now, right? And our height is 1. All right, final question, 2 parts. Rectangle S is 4 units by 5 units. So we have, okay, I guess I'll keep reading. 5.1, draw a scaled copy of rectangle S with an area of 80 square units. Label each side length of the scaled copy. Okay, so I'm going to do something first that's not actually, they don't actually tell us to do. I'm going to draw rectangle S. So they tell me it is 4 units. 1, 2, 3, 4, 5 units. Okay, this is going to be rectangle S, 4 by 5. And that has an area of 20 square units. Okay, that's my original. My goal is to create a scaled copy of that with an area of 80. So we want to think about, right, what can we multiply to get 80? And the best one that should come to your mind is 8 times 10. Right? I mean, there are other ways to get to 80, but I imagine that's sort of like anyone's initial thinking. Right? 8 times 10 is 80. So we can try to draw that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to need to erase this. This is 8, and this is 10. And that's going to have an area of 80 square units. Okay, so the question is, we started with rectangle S, where this was 5 and this was 4. And now we have a scaled copy, right, that has a scale factor of what? Well, it's pretty easy, right? It's our favorite scale factor. From 5 to 10, we're multiplying by 2. From 4 to 8, we're multiplying by 2. So we have a scale factor of 2. How do I know? Right, 5 times 2 is 10. 4 times 2 is 8. And then this meets the requirements, right? We have a constant scale factor of 2. And we can see that 8 times 10 gives us an area of 80 square units. So it's kind of a little bit of a guess and check work, but you want to make sure ultimately that you're drawing a scaled copy that has the correct area, right? And there's also this good scale factor that works between your 2 shapes. Cool. And this will be a setup on the computer. You'll have more room to explore and draw, so it'll actually be helpful. All right, great job, everyone. Good job studying. Remember, feel free to find me after school or at lunch if you have a question.